Hello YouTube. Last time I talked about hexadecimal numbering system. Today we're going to talk about binary. Each digit in binary is referred to as a bit. So right here we have 4 bits. If I have 8 of these bits, that would be considered 1 byte. Just so you can have an understanding of what the difference is between bits and bytes, yeah. So 8 bits equals 1 byte. 2 bytes equals 1 word. We won't get into that right now. We're just talking strictly about binary. But binary has also 2 parts. There's something called octal, which is in the numbering range of just 0 to 8. I believe that's correct. Yeah, that's called octal. So the first number in binary is naturally 4 zeros. The next number would be here in binary, 0001. And then you have to try to imagine kicking a 1 in here and displacing the one that's already there to learn how the sequence itself counts. So as this is 0, this is the number 1. Number 2 in binary would be represented as 0010. So like I said, you imagine kicking a 1 and displacing it and resetting the other one. So yeah, that will be the number 2. Number 3 looks like this. Since you're kicking in a 1, it had a place to go from the last number, so that 0 transposes to a 1. So now we got 0011 for the number 3. Well, what happens now when we kick another 1 in? Well, it's going to reset these 2, and then the 1's going to go over here. So that next number would be 0100. That would be the number 4. Like that. Okay. Now again, imagine adding or kicking in another 1 from the right side, going left. That would be 0101. That would be the number 5 in binary. Okay. Okay, imagine again kicking another 1 in. 0110 would be the number 6. Because as I said, when the 2 1s hit, they got to both reset and move over 1 bit position. Okay. Now the number 7 would be 0111. That would be 7, just like that. Okay. And the number 8, which would be ocho in Spanish, would be 1000. And that would be the end of the octal alphabet if you were using octal. You'd only be going that far with the digits. Everything beyond this bit being set wouldn't matter. These wouldn't matter because that would be octal. Okay, so there you have it. Now you see the pattern here. There is a pattern here. 0, 1. For the first digit, for the first bit digit, I'm sorry, 01010110. Okay? The second digit, there's a pattern. 2 zeros, 2 1s, 2 zeros, 2 1s, and then if we continued beyond 8, again, it would be 2 zeros. Okay? Third place, 4 zeros in a row, then 4 1s in a row. And then if we continue, it would be 4 zeros and so forth. And the last place, or bit 4, when bit 4 is lit or on, that would be the number 8. But then you would have all these digits to continue all the way up to, 16, I believe? Or 15? Yeah, 0 to 15, which would be 16 total digits. So that's how binary works. Like I said, an octal is just base 8. In other words, you don't use the rest of these beyond this bit being set. So that's how binary works. And just to give you another example, I built it here quick on my kit. I mean, it's nothing fancy. It's just an illustration. Let me move the camera back a little bit here and make some room here. Excuse the bumps. So what I did was I made a little thing here with switches and LEDs, and I'll just represent to you. Watch up here. Oh, excuse me. Watch up here the LEDs that represent a binary count from 0 to 8. So 0, nothing is lit. That would be binary 1, binary 2, binary 3, binary 4, 5, 6, 7, and 8. Now 9 would look like this. 10 would look like that. 11 would look like that. 12 would look like that. 13 would look like that. 14 would look like that. And then 15, all 4 bits would be lit. And then if we had more places to the left, these would all 0, and the next place on the far left, if I had it, would be lit up. So that's how binary works. So thanks for watching. Thanks for coming along. I hope you enjoyed. Please subscribe, and we'll see us all again later. Bye-bye.